intermolecular.
What will it?
Now, forces within molecules between the atoms are intramolecular.
Yeah.
Chemical bonds are what type of forces?
Wait,
Chemical bonds.
Can you say that again?
Chemical bonds are what kind of forces? The forces between different molecules are intermolecular. And the forces within molecules between the atoms are intramolecular. Chemical bonds are intramolecular.
I follow.
I would have found.
I would write this, not you could write this down if you'd like to.
Is it on the
Straight from the
The attitude just coming my way is crazy.
Chemical bonds are the same thing as intramolecular forces.
Right.
The chemical bond is the same thing as intramolecular.
Yeah.
I was just thinking, pick it up all the voices.
How is it within?
Within molecules between the atoms.
I actually don't know what either of those mean, so that's okay. Is the whole
Oh,
thing
period.
And then like the
No.
no.
Is the whole thing multiple? We're gonna have to draw some of that stuff.
1 through 20 is multiple choice.
Is there true or false?
No.
Thank God.
Yeah, for real. I would.
Is there any written questions?
No.
Okay.
How many questions are on the test?
I'm gonna keep spazzing.
Yeah.
I love that.
Now, what about an ionic bond? Are electrons shared in ionic bonds? No, they're transferred. They're transferred.
Bro, it's only been 2
So
minutes.
electrons are transferred in ionic bonds.
It's still a little hot in here.
You have different pictures to just depict bonds. Yeah.
That's shared.
Yeah, covalent. And that's a lattice thingy, so like metal, right?
This is lattice. What is this bond? This
Metal.
isn't metal.
Metallic.
Mm-mm.
Same thing.
Which one's shared?
Covalent.
Yo,
No,
mama.
which one's
Ionic.
ionic? So
Yo, mama.
covalent, ionic, and then this one is the one where it was
Metallic.
metallic.
I thought they
Right
they
there,
were
close
lattice.
together.
I would show, but like,
They have a sea of these.
Yeah, but
I'm gonna forget
isn't it
that.
Like a lattice
That don't-
thingy too?
It's a sea of these. The electrons are just scattered around them.
Yeah. I didn't
Right.
They're together.
I thought
So which
there
one's
was
which?
No,
Oh my gosh, this one over.
you're maybe thinking about this structure.
What's the
It's
name?
just like this.
something about those.
covalent, ionic, metallic.
Covalent, ionic, metallic. Okay. What atoms involve the formation of metallic bonds?
Polyatomic.
Non-metals, metals, metals.
Metallic? You said?
Yeah, metallic bonds are formed from just metals, right? Metals only. What describes atoms involved in the formation of ionic bonds? Non-metals only?
Non-metal and metal.
Okay, it could be non-metal and metal, but don't let that trick you,
Say that one
because
more time.
think about polyatomic ions. Polyatomic ions are charged groups of atoms, correct?
Right.
So the atoms involved in formations of ionic bonds are going to be charged atoms or groups of atoms.
Comprendo.
Charge.
Capiche.
Atoms or groups of atoms.
Charge.
Charged
Did you say charged atoms are?
or groups of atoms. Charged atoms and charged groups of atoms. Bond.
Because like
form ionic bonds. Yes, it's the ion.
Yeah.
Okay, now covalent bonds are bonds formed from
Non-metals.
nonmetals only.
What?
Right.
Becca, listen.
I did. It was. I heard what?
Yikes.
Now, if you're given
Oh my god.
Charged atoms or groups?
Charged atoms were
Quit
groups
moving.
of charged atoms.
yeah,
That's sulfur hydrogen.
like polyatomic ions.
And then covalent is non-metals only.
Sulfur is S.
Yes.
Okay. Some of them weird.
Okay, if you're given something like this, and you're asked how many atoms are in this compound, how what would you say? 5?
What?
6. This one's under sulfur. So you have 1, 2, 3, 4, 5, 6.
I hope so.
So there's 6 in there?
Yeah.
And it just tells you, right? Yeah. That's the
Well, you
question.
know, like thinking here.
No,
Right.
but that's what I'm saying, like in ionic,
It
you
tells
sometimes can't just look at it.
Yeah,
Yeah.
because you have to, it can be reading. But if it's,
Just ignore it.
Give her a
Okay.
second.
Oh, I like that.
sorry. Oh, okay. Now, if you're given something like,
Moment,
give me a
please.
transition metal.
Gold.
Gold is what, AU?
AU.
AU. And now give me,
Oh.
iron. No, not iron.
So,
Yo, mama.
We'll do Li.
what are we supposed to have that mean in this period?
Okay.
What do you mean?
The,
Now,
what are you in about?
if you're given, no, I can't just come up with an example. If I do that,
Ooh.
I'll get you one.
I need one that's like, is actual, like,
MN.
in,
Like, little n. Yeah, right? Open parentheses.
uh-huh,
O.
uh-huh,
A.
okay.
Parentheses. 2.
Okay, there we go.
There we go.
Okay, now if you're given this and you're told to write the name
Bless
of
you.
this, Mn is a what?
Manganese.
Is it a transition metal?
Metal.
Yes.
It's a transition metal, so we don't know its charge, right?
Yes.
But OH, we know its charge. What's its charge?
2.
2.
Period. Alice is always getting on to them.
Okay, it's 2 negative, correct? Okay, so this would have to be,
Pause.
No, OH is 1.
OH
Wait.
is 1,
Yeah.
1 negative.
Because it's a poly. Yeah. Poly.
Come on, come on.
Same.
I don't know what the frick is going on.
It was in our examples on our study guide, the one
Yeah.
Who knows?
And we have 2 of these, correct? So we have 2 times 1 negative, which is what? 2 negative? Well, this needs to be 2
I
negative.
feel like I've been here for an eternity.
Okay, so when we're writing this out, it's gonna be manganese?
Yes.
2. And then what is this polyatomic, what is this? Hydroxide?
Like, doesn't the 2 on the original thing just like go to the MM?
This
Do you need
2
that?
on the original thing
No.
that goes in? Not technically.
Okay.
So you have 2 of these. There's 2 hydroxides, right? There's 2 of them. And they each have a 1 negative charge. So 2 times 1 negative is 2 negative. So I need this charge to cancel this charge out.
But it doesn't. Would that have to be 2 plus? To
Oh,
cancel?
yeah, sorry. My bad. 2 positive.
No.
But the point of the 2 is to
Oh.
know what Roman numeral you need there.
You need a new marker. Where's Chris?
Yeah, you. Oh,
Yeah?
Sorry, I couldn't find Chris.
where'd he go? Oh, he in the front.
Monkey does.
Ooh.
Okay, we'll do another one.
Oh, there's one. There's that one.
Okay,
You could just zoom
this
in.
is what? Nickel, what's its charge? We don't know. Okay, oxygen, what's its charge? 2 negative? Okay, so we have one oxygen with a 2 negative charge, so that's 2 negative. So we need this to be 2 positive to cancel out and make it 0, right? So this needs to be 2 positive. So when I name this, I'm going to name it nickel 2 oxide.
I'm talking about the game.
Yeah?
Sure. Huh? I don't think she likes me, period. Right.
Do you want another option? Wait, hold on.
I was writing that.
Chris will send you the picture of it.
Yeah. Okay, I think I can figure it out.
I thought you meant to leave that one first. I don't want to do the stupid right questions.
Okay. If a compound is most ionic, if you're given a temperature, like scale, like a temperature scale, so you have like negative 200 degrees Celsius, 300 degrees Celsius, 400 degrees Celsius, and 800 degrees Celsius. Which one of these is more ionic?
Hold on. Wait, what you asked?
Which one of these would be most ionic?
300.
We haven't done the
100.
They have a high what? It's melting point. These are melting points.
So 800?
800.
800. This one would be ionic. So what about covalent?
200.
Girl, what?
Would be the negative 200.
So I just gotta put it's the lowest one on that side. Or whatever. Yeah. I make sense in my head. Somehow, in some way, and it makes sense. Bro, what the?
How many atoms is in this? 3.
1 barium, 2 oxygen, 2 hydrogen.
Yeah, 1 barium, 2 oxygen, 2 hydrogen, so there's 5 atoms.
Period. Boom, shakalaka. Yeah, because the 1 and then there's 2, 2. Yeah.
I thought I was at an estimate. I really did. I was like, what's a saddle?
Wait, I'm curious. Maybe I don't even know how to do how
What are you guys cooking on 800?
I know the one I'm working.
What's being cooked at 800? I don't think that's safe. That chicken would be burnt in like 2 seconds.
Okay, as far as electronegativity goes, if it has the greatest ionic character, its the electronegativity between the atoms are going to be high or low? Higher. The greatest ionic character has higher electronegativity.
The greatest what?
Ionic character, like. Listen, I'm going over this like directly from the text. So if y'all don't do good
It
on
has
the
the greatest
test,
ionic character, has the highest electronegativity.
Yeah.
There's 1
Boom.
barium, there's 2 oxygen, there's 2 hydrogen. There's 5 atoms.
Boom, shakalaka.
alright. So the least ionic character would have the lowest amount of electronegativity, correct? Because you're going to be given compounds and you're going to be in elements and you're going to be asked which ones have the greatest and which ones have release.
What is that noise?
Okay,
Shut up.
what is
Wait, so it's more ionic if it's got a higher electron? Okay.
what are the following? Okay, so what's true about cations? Are they typically not metals?
I thought you said there wasn't gonna be true or false.
Typically metals.
Not metals, right?
I just don't. I don't.
Do cations have
Cations.
Don't ask because she ain't gonna tell you yes or no.
They're positive. They're positive, so then
they have positive oxidation?
they that means they lost. That means they're on the left side of the periodic table.
Oh, the ones
Right.
on the left are gaining it, so they're anions.
Wait,
So non-metals are anions.
y'all confuse me.
This doesn't make sense.
Speak the truth.
Just answer the question.
Just straight.
Wait, what was the question to start off with?
They're on the left side of the periodic table. Yeah.
Yeah, so
Yeah, but
they're metals.
they're typically metals, yeah. Yeah.
So the answer is metals.
I just know that they're positive.
This is gonna confuse me. No, I'm not gonna lie.
It's like fluid is much more likely to
Just know the answer is metals
and it's not.
for that one. Yes,
So cations
I might need that.
Yeah. Okay,
Could
so
you-
we were talking
wait,
about
it's like-
the pictures, I already went over that.
Yeah.
An unknown substance is solid at room temperature, it's malleable, it can conduct electricity and thermal energy easily, so it's most likely a what kind of compound? Metallic compound.
No.
If I put metals down,
Solid at room temperature,
if I put metals down,
malleable, can conduct electricity.
Oh, that's the four.
Yeah, the
Yeah,
They're probably
malleable,
metals.
ductile,
if I put down just a metal,
electric, or thermal electric,
The
and
light
then
one.
absorb and reflect.
so I'm gonna put it like metal.
Okay,
Do you know
you were
any of
talking about
that?
this earlier. Anions, do they gain or lose electrons?
They hold on. They gain
Gain electrons and they have a, what kind of charge?
negative,
Negative charge. Cations
positive, and they
lose.
yes.
Okay?
It takes me a second.
Okay. Okay, now listen to this one. An unknown substance is solid at room temperature. It has a high melting point, and it can conduct electricity only when it's dissolved in water.
Ionic.
So it's an ionic compound. Yeah.
That's good.
Electrons are considered delocalized when they are in a what kind of bond?
Metallic.
Metallic bond. Because they're like the C of E.
Say that again.
Electrons are delocalized when in a metallic bond. In a metallic bond. Okay, now we're going to go into the open response question.
Yes, please.
But the open response questions aren't going to require like a paragraph. It's just like a sentence or like a
Electrons are considered
Let me turn around for them sentences.
Or do the place in
in a
the
metallic bond.
You can try.
Ionic bonds can only conduct
If I make a bad grade, it's because of
When
you.
they're dissolved in water.
Not me.
Yeah.
Okay.
Yeah, like you ain't gonna use this though.
Bonding is considered a spectrum. Why?
Because there's not just two types. There's ionic and covalent and nonpolar at some two extremes. I don't know what that means.
Yes, because there's not just two types. But is it just there are 3 bond types, and it's all based on electronegativity, right?
Alright, so how much you want?
I hope they picked up what she said.
Like a sentence, some are a sentence, some are just a word. I mean, because this one literally says, explain what is meant by the statement bonding is a spectrum. Well, there are 3 types of bonds,
It's not an answer.
and the bonding is based on the electronegativity.
So is there ionic, nonpolar, and polar? Is that 3?
There's ionic bonds, covalent bonds, and metallic bonds. That's the bonds that we're talking about. Like this next one is, it's gonna give you a statement, and you're gonna, based on that statement, tell me if it's ionic or covalent. So that's just a word, right? Okay, so electrons are shared.
That's
In a
ionic.
what kind of bond?
Covalent.
Covalent. high difference in electronegativity, ionic. High melting point, does not include metallic atoms. Most likely to be solids at room temperature,
Ionic.
ionic. Mostly liquids or gases at room temperature, but can be solids, covalent. Can have an electronegativity difference of 0 between the atoms, covalent. Can conduct electricity when dissolved in water, ionic. And then it's going to give you some, like, compounds. I do need a marker. KS2.
Potassium sulfide.
Okay, potassium sulfide, and that is a what kind of bond?
That mark on it.
That's
Ionic.
Ionic.
Boom.
Okay.
1 out of how many?
1 out of like 100.
How many questions are there on this test?
I don't know. I do know, but hang on.
Bro, where's your phone?
33.
I think it's not 10. And we already know like 20 of them.
Okay, what about like SiCO4?
I mean, for how long we said?
Silicon chloride.
Sulfide.
Yeah, after all.
Covalent. Okay, what about this one?
And nitrogen, hydrogen.
I mean, these are typically not in,
So they're both polyatomic?
yeah, they're typically not in, they're not gonna be written in parentheses because there's not more than one of them. Does that make sense?
So ionic.
It's gonna be written like this and it's ionic, yes, because it's polyatomic ions. What about salt?
Those are metals.
Sodium chloride is,
Miss Powell,
yes. Yes,
I need Emery Johnson to check out, please.
okay, she's on her way. What? NaCl. Where are you checking?
Salt.
Salts.
Salt, right?
That's a metal.
That's a what?
Metal.
Metal?
Yeah.
So what kind of bond is this?
Metallic. Covalent.
Metal and
That's ionic.
ionic.
Bye, have fun.
Okay.
What'd she say it was?
Ionic. So if
So
it's a
wait, is this the right side of the periodic table is non-metals?
Is there an element that's a metal? Are either one of these metals?
yeah,
Yeah?
sodium.
Sodium's a metal? Yes? So, ionic.
Boom. That is that easy.
It's on the back.
Okay.
Okay. Okay, now, this is easy. Explain how sodium chloride is a neutral compound, despite it being composed of positive sodium ion and a negative chlorine ion.
They cancel out.
Because they have a 0 charge. Correct?
Is it that easy?
Because this is like negative. How would sodium chloride, negative one, this is net positive one?
You have 2 pennies.
Yeah,
I got more.
Oh,
that's how you explain that. Now explain why only covalent compounds are referred to as molecules. Instead of compounds. Why are they referred to as molecules instead of compounds?
I don't know. This is
Because you can look at one molecule on its own, whereas in ionic compounds they're like in lattices.
Oh, because they
They're
create
another
a thing.
Yes,
It's
they
not a
create a
compound.
lattice,
Okay.
yeah.
So covalent makes a
Molecule,
molecule
yes.
instead of two separate.
Individual covalent compound on its own. You can look at one of the individual covalent compounds on its own. Because they share electrons as opposed to transferring them. Okay.
And covalent, sorry,
Yeah.
covalent compounds can be looked at on their own.
Yeah, you can look at one individual covalent compound, one molecule of that on its own.
This class is stupid.
Now, explain how the nature
I hate
of
it
the
here.
atoms in an ionic bond contribute to the formation of the crystal lattice. Then include at least 2 examples of ionic properties that result because of this structure. I'm just gonna, the negative anions are attracted to the positive cation, right? This is why the lattice is formed, because negative attracts positive and that's what forms the lattice.
So it's formed from anions and
The attraction between anions and cations.
And this forms lattice.
Yes, and now as far as the properties, one example of a property is that it makes it strong, makes a strong bond, giving them a high melting point.
Wait, is this still about lattices?
Yeah, this is
This is the
this is 2 examples of the properties that result
high melting
because
point.
of the lattices. As a result of the lattices, the 2 properties that result. One of the properties is that they have a high melting point.
We have to read up and read faster.
Okay. Okay, and then when dissolved in water, they can conduct electricity. Because they have metal.
Wait, I'm sorry, what was this?
Whenever they're dissolved in water, they can conduct electricity because they contain metal atoms.
Conduct electricity in water.
And the first one was Powell.
Yes.
What time do y'all read? Do we have enough time? We still have enough time to get 49. Oh, we have plenty of time.
Wait, because they have metal ions.
Because they contain metal atoms.
How far are we into the test?
Now we're on 26.
Out of
56 out of 32.
okay.
Okay, so it says consider a compound that will most likely form between something and something. So I have 9. Let's do sodium. Wait, I'm just gonna write sodium because it's not gonna give you the symbol. It's just gonna say sodium. It's gonna give you the word. Sodium and what's the other one it gives me? Sodium and sulfur. We'll just do sodium and sulfur. Okay, so now it says A. Would it be ionic or covalent?
Ionic.
So you would write beside A, you would write ionic, right? And then for B, it says draw the Lewis structure to represent the compound that was formed. Okay, sodium. Sodium's in A, and it has 1 valence electron, and sulfur is S, and it has 6. Yeah, 6. Okay, so it has 6. So this one is going to go here, and I need how many more? 1. So I'm going to write another NA, and that one is going to go there. Okay, so this is not my Lewis structure. My Lewis structure is going to look like this. NA, and it's got, what's the oxidation? Right, 1 positive,
Plus.
and then NA, 1 plus. And then I have sulfur. That it's got a full, I'm just going to write it. And then it is 2 negative.
If you've got 2 in the back, do you put them all in one bracket or you put them in each individual bracket?
Say it again.
Like if I had like 2, yeah, one bracket, 2 brackets or 1 big bracket.
Yeah, brackets.
Is that one?
Okay?
Just a nice show.
Alright. That's full of instruction. That was C. There's no instruction. So now C says, write the chemical formula for the compound. But
Is this still all number 27?
26.
So that's just
26 and 27 is the same. And there's more than 3 parts. There's 5. Yeah.
Is it
So what
Na2?
is the chemical formula for this compound?
Na2S.
Na2.
Either. Okay. Okay.
Okay, and then you have B. What's the chemical name for this compound?
Sodium.
Sodium sulfide.
And how many are on?
Yeah.
It's 2.
Okay, that's not bad. That's not bad.
Sodium sulfide. And then E.
E.
It says, why would they form this bond?
So one's a metal and one's other thing.
I don't know what this is asking.
To become stable.
That's what I was thinking. It's the opposite.
Not bad.
Bruh.
Where you put to become stable?
Yeah.
Just put that on every other question
Form
then.
this bond would be to become stable.
Okay, fire.
Boom.
So like, if there's like a second one of that, would the other one also be to
That
become
is
stable?
all-
So this one, there's another one exactly like this
Another
one.
one exactly like that one, except it's got a transition metal.
So why would that one want to be a bond?
Wait, no, it does not have a transition metal.
To become stable.
Bro, what?
Yeah, because we couldn't do that with, well,
Yeah, no.
I think that would, with like the electrons.
So, yeah.
Yeah, it's not.
Yeah,
Now, number 28 is going to be naming, like we did on our quiz. Number 28, there's 5 of them, just like on the quiz. It's going to be naming. And then number 29 is going to be writing chemical formulas. There's 5 of them, just like on the quiz.
Can I get my quiz back? I studied my quiz. I'll choose worksheet.
Just so we can like have examples.
Did I think I put an answer key to one of them on the,
Like, I
there's
have
an
that.
example.
I'll just use my
yeah. But really quick, I'll do an example of one. Of what?
naming
Let's do a
and,
transition one.
yeah,
Yeah.
of the naming and the,
Just everything.
The naming and the thing.
yeah,
I'll
and
have
the
to make that up. Let me see which one of these is transition. I'll do the hard one.
Hard one.
P. And then I have P.
Lead, carbon, oxygen theory.
Sleepy. I don't want to go to bed.
Okay.
No.
Lead,
So
carbon.
CP, I don't know its charge, right? And then CO3, what's its charge?
See it.
It's a polyatomic ion, so what is on the
2
charge?
minus,
Something.
2 minus, this is carbonate.
2 negative, right?
Sure.
Okay, how many CO3s do I have?
2.
2. Okay, times 2 negative equals 4 negative. So what does this need to be?
4. Or no,
For it to equal 0, what does that need to be? 4 positive.
Why didn't we know that?
But, so there's just the 4 on.
We need to know that for the wrong example.
Like,
Can you get out
So
of
this
the
is
way?
going to be, huh?
this is like 4.
Can I get it?
Well, it's either positive,
No, it's just
it's either positive or,
So we do that because we don't know if it's positive or negative.
right.
it's lead 4.
I think this is all really bad.
4. And then that's what? What's that called?
Carbonate.
Yeah, carbonate.
You know this. You don't need this.
I know this, but it's other transition.
Aren't those still transition metals?
I don't know, it's not a transition metal. Where's my,
No, focus. Okay.
There's like, some that still go through. Yeah.
But when it breaks,
It's a post-transition metal, so it's still considered a transition metal. So aluminum,
Maybe it's a
gallium,
transition metal. What do I
indium,
mean?
gallium, tin, lead, bismuth, and polonium, those are transition metals.
Would we still need
Bismuth.
Have we ever done that for aluminum? Have we ever done?
I don't think we've done an example.
No, yeah, we never did a Roman numeral for aluminum. Well, let's just do 3.
I don't really.
Have we written, we've never written, we haven't done an example with aluminum yet, have we?
No, I'm saying whenever we do aluminum, on all our papers, we always do the +3 charge.
Yeah, because it's.
Oh, okay. I was talking about naming it. Have we ever done it
I don't know.
going from here to here?
I think so, but not when we don't ever have the Roman
Yeah,
numeral.
I've never.
So that's what we're saying. He was saying, well, wouldn't you just do the 4 for lead? Like, do you, or do you have to do all?
But it's considered a transition metal. But this is an example of how you would find this number.
So it's the
If
same
you didn't
way.
know it was anything.
Okay.
Even though we do know it because we have it. You can use this as an example if you don't. It's like in the middle. That worked out the same.
So you always just do like, whatever they give you, so there's 2 carbonates, and then you go, like, even if it was like sulfur, you'll go and find the, whatever the charge is, and you multiply those, and you make the other equal it, or cancel it out.
I know you always say
Yeah.
find out what the charge is,
And then
multiply
try to
by
find
how many you have, and that's what.
find the opposite.
And then you find,
Okay.
yeah, opposite of that, and that's the Roman numeral for your transition metal. Okay?
I don't think I understood that whenever I did my quiz, but I still got all of it.
Okay, so now if you have, if you're given like nickel, 2 phosphate, and you're asked to go backwards, nickel is what,
Yes. And then it has a
and it's
2
going
plus.
to be 2 positive because of that. This tells us what that is.
And phosphate.
And the phosphate is what?
PO4 3 minus.
Okay, then you would take this and move it down here and this and move it down here. So you would have Ni3,
Hey, and I'm
she can wait.
PO4.
Well, the person that we need to talk to her about is in here. No, because I didn't know that's what she was still doing. So we can figure out. I was like, I'm not telling her.
Okay, so that was 28 and 29 are gonna be like a few of like 5 of each of those.
5?
Going from here to here and then going from here to here.
Okay.
Okay? Now number 30 is asking you like a nutrition label on a bag of potato chips. It lists having sodium in it.
Kind of bad potato.
Now sodium, it reacts violently when it comes in contact with water.
Yeah, and then chlorine
So why do you not
is
explode?
toxic.
Why do you not explode when you eat a bag of potato chips?
It's stable.
Not pure sodium, it's sodium chloride.
I know where I got chlorine from.
So you would write that as your answer because it's not pure sodium. When what they're referring to as sodium on the nutrition label, they're referring to sodium chloride.
Table salt.
Because it stables out when it's on.
Now, number 31 is asking to describe the property of metals that makes them shiny.
That's
They have a reflective surface.
yeah, reflect. Yeah.
Is that it?
Getting there.
That seemed pretty easy.
They're good absorbers and
Good
reflectors of light.
reflectors.
That's really silly to stop if you have a question.
I should give everybody that question.
No, you should get rid of it.
I'm not giving it. I have to have some easy questions on
Oh,
it.
the reflector?
Yeah. What is it? I have to have some easy questions.
Like too easy.
All right, number 2. Explain how the structure of metals impact their ability to conduct electricity.
It's really strong.
Huh? The sea of electrons and metallic bonds, they allow the electrons to flow through the material more easily. creating electric current and making them good conductors of electricity. So,
Yeah.
because of the sea of electrons.
They make them good conductors.
Yes, makes them good conductors of electricity.
Well, you just ever feel
It
like
allows
the reason why-
electrons to flow through the sea of electrons.
This is stupid.
All right, lavender reflector.
One more.
Hmm?
One more.
No,
I'm
last
so
question.
done. No.
This is, I'm
So
talking
you
about
the C of E makes them good conductors
This in life
of
is not a good thing.
electricity because
the electron, it allows electrons to flow through,
Same.
creating an electric.
I didn't even go to work. I was so happy about no. Oh, I need to go on with my
So
phone.
we had like one more, so we get the last two real quick. That's the last one.
I'm doing the last one right now. Okay, give an example of an alloy. So you all had, you all had an alloy. You
oh we don't gotta do ours right. I hate mine. Sounds like rabbit.
all it says is give an example of an alloy.
I'll let
So
20. Easy.
what was an alloy that someone had?
I'll let 20.
Bronze.
Alright, okay.
Okay, bronze.
Did it?
Why? What metals make up bronze?
Copper and tin.
Copper and tin. And how does it structure made and how
Okay,
is
now.
it used? So I would use
They have
not,
stronger metals.
yeah, forms of stronger metal. I would just use the alloy that I was assigned because you know the most about it, right?
Hey, you got a question?
My alloy had like 6 metals.